So let's dive into Introduction to Security, Identity and Compliance Services in AWS, which includes finding compliance data with AWS Artifact, managing users, groups and roles with AWS Identity and Access Management or IAM, evaluating the security of your AWS environment using AWS Trusted Advisor. So let's explore cloud security in AWS. AWS is responsible for the security of the cloud, including global infrastructure elements like region, availability zones, and edge locations, as well as the foundations of compute, storage, database, and network services. So once the data is put into the cloud, the responsibility shifts to the customer. It includes encryption, network traffic protection, operating system security, firewall configuration, application security, and identity and access management. It's crucial to tighten security to minimize exposure to external threats. The level of additional security you implement in your decision depending on the nature of your business and existing controls in place. Remember, while AWS provides powerful security controls, how often and when to apply them is not AWS responsibility. So AWS Artifact, the self-service portal that provides immediate access to AWS security and compliance reports. To access AWS Artifact, simply search Artifact in the AWS console. From there, you can view reports and agreements. AWS Artifact reports includes ISO certifications, PSI, and SOC reports, which are crucial for providing evidence of AWS security controls for compliance with governance, regulations, and frameworks. Remember, AWS is responsible for the underlying security of the cloud while you remain responsible for your systems and applications security in the cloud. In addition to reports, AWS Artifact allows you to view and execute legally binding agreements such as the AWS Business Associate addendum for storing personal health information. By using AWS Artifact, you can ensure that the solutions you architect in AWS Cloud remain secure and compliant with all necessary rules and regulations. Access AWS Artifacts today to stay on top of your security and compliance needs. So let's dive into what Identity and Access Management IAM services actually means and how it's crucial for securing your AWS accounts. IAM involves two key stages: identity management and access management. Identity management is about defining how you are and verifying your identity. For example, your AWS username serves as your unique identity within IAM. Access management, on the other hand, focuses on authorization and access control. It determines what resources and identity can access within your AWS account. These includes permissions for specific AWS resources such as EC2 or RDS. IAM utilizes various authentication methods, including username and password, multi-factor authentication, and federated access. These mechanisms ensure secure access to AWS resources without compromising on identity verification. In essence, IAM empowers you to manage, control, and govern authentication, authorization, and access control mechanism within your AWS account. Understanding these security controls is vital for designing the right level of security for your infrastructure. Features and components of AWS IAM. Let's dive into the key aspects of these crucial service. So when accessing the IAM service through the AWS Management Console, you will be greeted with the IAM Dashboard. Here you can customize a sign-in link for users, view a summary of your IAM resources, and access a list of IAM security best practices recommended by AWS. Under access management, we have components like users, user groups, roles, and policies. User represents identities and user groups are used to authorize access to resources. Roles allow temporary permissions and policies. Written as JSON documents, define access rules. If you're looking to provide federated access, you can add an identity provider. Additionally, under account settings, you can enforce a password policy and configure the security token service for temporary credentials. Moving on to access reports, the access analyzer helps identifying external access to your resources, while the credential report provides a comprehensive overview of IAM users and their credentials. Understanding these features and components is crucial for maintaining robust security within your AWS account. AWS IAM User Console Dashboard. Let's dive into the key features and functionalities of this powerful tool. When you open the AWS IAM Dashboard and select Users, you will find a summary of key points of interest relating to your IAM users. These includes last activity, MFA status, password age, console access, and more. The dashboard provides detailed information such as the user's path, groups they belong to, last activity, MFA status, password age, console access, and more. These allow you to easily manage and monitor user accounts. You can also view and manage access keys, including the age, last used, and associated ARN. These helps ensure secure programmatic access to your AWS resources. In conclusion, the AWS IAM User Console dashboard provides comprehensive insights and controls for managing user identities and access within your AWS environment. AWS Management Console, where creating a new user is a simple process. Let's dive into the steps to configure a new user. First, set the username up to 64 characters in length and select the AWS access type, either AWS Management Console access or programmatic access. For programmatic access, an access key ID and secret access key ID will be issued. If console access is required, define a console password for the user. You can attach permission policies to the user or inherit them from a group. Permission boundaries can also be applied to control the user's maximum permission level. Review and confirm the information submitted before creating the user. Once the user is created, download the security credentials via a CSV file containing the username, access keys, and console login link. Creating a new user in the AWS Management Console is quick and straightforward. IAM User Configuration and Security Options. Let's dive into the additional features available for IAM users. In the IAM dashboard, we can view a user's details such as their ARN and creation time. We can also explore different tabs, starting with the Permissions tab, which displays the policies the user is getting permissions from. We can set the user's permissions boundary, generate policies based on the cloud trial events, and add an inline policy for the user. Additionally, we can review the groups the user belongs to, manage tags, and handle security credentials, including setting up MFA and managing access keys. The Access Advisor feature allows to review the services the user can access based on their permissions and the last time these services were accessed. This is crucial for ensuring users have the appropriate access. These are just a few key points to consider when configuring IAM user properties. Stay tuned for more insights on user management and security options. IAM User Groups, a powerful feature that simplifies access management at scale. IAM user groups are objects that contain IAM users and have IAM policies associated with them. These policies can be AWS managed, customer managed, or inline policies, allowing you to authorize access for members of the group to AWS resources. By applying permissions to a group instead of individual users, it becomes easy to modify permissions for multiple users at once, simplifying access management at scale. This is a security best practices that prevents the need to update permissions for each individual user. Creating a group is a simple three-step process. Give the group a meaningful name, add users to the group, and attach permissions via policies. Once created, you can easily review its configurations, edit permissions, and see their details. IAM user groups are a game changer for managing multiple users in your AWS account. They streamline access management, reduce the risk of human error, and make it easy to modify permissions at scale. IAM roles work in AWS. Let's dive in and find out how they allow trusted users, AWS services, and applications to adopt a set of temporary IAM credentials to access your AWS resources. IAM roles act as identities, much like users do, and have permissions assigned to them, defining what resources the roles can and can't access. Unlike users, IAM roles are designed to be assumed by multiple different entities as and when required. Roles are used for temporary access to gain access to resources, and each time the role is assumed by a user, an AWS service, or an application, a new set of credentials is dynamically created for the duration of that session. IAM roles are generally used to grant temporary access for users to AWS resources that they don't normally require access to grant access for an IAM user in one account to access resources in another account, or for an AWS service or an application that requires access to resources. Roles can be assumed by a user in the same AWS account, a user in a different AWS account, an AWS service such as EC2, or an external federated user to your AWS account. So, IAM roles provide a secure and flexible way to manage access to your AWS resources. So, ready to give it a try? So, let's dive into AWS IAM policy types. So, let's explore the four main policy types within AWS IAM and clarify their distinct functions. Let's start with identity-based policies. These policies are attached to users, user groups, or roles, controlling their permissions. They can be managed or inline policies, offering flexibility in permission management. Moving on to resource-based policies, unlike identity-based policies, these are associated with resources such as S3 buckets or IAM roles, defining access to the resource level. The next is we have permission boundaries. These policies set the maximum level of permission for a user or role, acting as a guide rail to limit access. Lastly, we'll discuss service control policies. So SCPs are used at the AWS account level to define maximum permissions for all members, providing an additional layer of security. So by understanding these policy types, you can effectively manage permissions within your AWS environment. Let's dive into AWS Key Management Service, KMS, the essential tool for securing your data in the AWS environment. KMS is the backbone of encryption for AWS services, ensuring the security of your data at rest. It provides the means to generate and manage encryption keys, enabling you to protect your data across various AWS services. KMS is built on various key components, including AWS managed, customer managed, and data keys, each serving a specific purpose in the encryption process. KMS seamlessly integrates with AWS CloudTrail, allowing you to track and audit the usage of your encryption keys, ensuring compliance and governance within your organization. In summary, KMS is the cornerstone of data security in AWS, providing the necessary tool to encrypt your data at rest and remain compliant with your organization. AWS Trusted Advisor, your go-to tool for optimizing your AWS infrastructure. Let's explore the key components and benefits of these powerful service. AWS Trusted Advisor is a service that provides recommendations to optimize your AWS environment based on the best practices. It covers 5 categories: cost optimization, performance, security, fault tolerance, and service limits. Trusted Advisor offers over 115 different checks, constantly updated to ensure the most accurate recommendations. It's important to note that access to these checks depends on your support plan with AWS. With a business and enterprise support plan, you gain access to a wealth of additional checks and features, including the ability to track changes, use the AWS Support API, and integrate with Amazon CloudWatch. Even without the premium support plans, everyone can benefit from features like Trusted Advisor notifications, exclude items, action links, and access management. Whether you're looking to save cost, enhance performance, or bolster security, AWS Trusted Advisor is an indispensable tool for optimizing your AWS environment. AWS WF service. If you're delivering web content through CloudFront distributions, Amazon API Gateway, REST APIs, application load balancers, or AWS AppSync GraphQL APIs, implementing the AWS Web Application Firewall service is crucial for an additional layer of security. Without a web application firewall, your websites and web apps could be exposed to harmful traffic, leading to potential security risks with significant financial and reputational impacts. The AWS Web Application Firewall helps prevent malicious attacks by common web attacks pattern, including those outlined in the OWASP top 10 list, such as SQL injection and cross-site scripting. In addition to custom criteria such as filtering requests based on source IP address or country of origin, AWS WF interacts with Amazon API Gateway, Amazon CloudFront, Application Load Balancer, and AWS AppSync to filter both HTTP and HTTPS requests, distinguish between legitimate and harmful inbound requests. The essential components of AWS WF include Web ACLs, rules, and rule groups. Web ACLs are associated with supported resources to determine safe web requests, while rules contain specific controls and criteria checks. Rule groups, on the other hand, are a collection of rules that can be applied to different web ACLs as needed. By implementing AWS WF, you can mitigate vulnerability risks and protect your web application architecture with a quicker, simpler, and more manageable solution. So if you're ready to enhance the security of your web application, let's dive into the world of AWS WAF. So overview of AWS Firewall Manager. If you're responsible for security across multiple AWS accounts, AWS Firewall Manager is a powerful tool to simplify your management and protection efforts. This service provides security protection for various resources across different AWS accounts, making it a crucial asset for organizations with complex infrastructure. AWS Firewall Manager integrates with AWS WAF, AWS Shield Advanced, AWS Network Firewall, VPC Security Groups, and Amazon Route 53 Resolver DNS Firewall. It also works closely with AWS organizations, which is essential for using Firewall Manager. So to start using Firewall Manager, you need to designate an AWS account as the Firewall Manager administrator account and ensure it's part of an AWS organization with all features enabled. Enabling AWS config and sharing with AWS organizations are crucial steps in the setup process. Finally, you must enable regions for Firewall Manager to manage resources within them. Once these initial steps are completed, they are ready to configure AWS Firewall Manager and its policies. So understanding DOS and DDoS attacks. So denial of service DOS attack aims to deny users access to a computer system or application by overwhelming it with bogus requests, rendering it unable to function properly. In a distributed denial of service DDoS attack, multiple sources flood the target system with bogus requests, creating a massive volume of traffic that poses significant challenges for mitigation. DDoS attacks are exhausted through botnets, a network of compromised computers controlled by dot masters who can remotely send commands to launch coordinates attacks on specific targets. Some common types of DDoS attacks include ping flood, which overwhelms a victim's network with pings, and SYN flood, which consumes servers' resources to make the system unresponsive to legitimate traffic. Understanding these attacks is crucial for implementing effective network protection and business continuity plans. So stay informed and stay protected. So AWS Shield and its protection levels. So AWS Shield is a managed service designed to protect your AWS application resources from distributed denial of service attacks. It automatically detects threats that may impact your environment and integrates closely with other AWS security services like AWS Web Application Firewall and AWS Firewall Manager. AWS Shield offers two protection levels, standard and advanced. The standard level is free and provides protection against common layer 3 and layer 4 DDoS attacks, while the advanced level offers enhanced protection against a wider scope of AWS services, including layer 7 attacks. The advanced level includes features like the Shield Response Team, layer 7 protection, enhanced monitoring, Route 53 health checks, protection groups, cost protection, and integration with AWS Firewall Manager. While AWS Shield Standard is free, AWS Shield Advanced comes with a cost of $3,000 per month. In addition to the data transfer out fees for all protected resources and requires a 12-month minimum subscription. Visibility and monitoring. Both levels provide insights into DDoS events, but AWS Shield Advanced offers additional monitoring features and the ability to gain visibility across multiple accounts. Amazon Inspector. Are you responsible for the security of applications, processes, and tools running on your EC2 instances? Amazon Inspector is here to help. Amazon Inspector offers a knowledge base with hundreds of rules mapped to common security compliance standards and vulnerability definitions. These rules are regularly updated by AWS security experts. You can also install an agent in the operating system of an Amazon EC2 instance to monitor behavior like network, file system, and process activity. With Amazon Inspector, you can automate vulnerability assessments to make security testing of EC2 instances a regular part of your cloud operations. These results in a prioritized list of findings, ensuring the security of your EC2 instances. Amazon Inspector, your solution for protecting the security of your EC2 instances. Amazon Guard Duty, an intelligent threat detection service for your AWS accounts and workloads. Amazon Guard Duty uses trained machine learning models to identify suspicious user and resource behavior, providing accurate threat identification of your account's data and workflows. The service analyzes CloudTrail logs, VPC flow logs, and DNS query logs to identify issues worth looking into, ensuring comprehensive monitoring and protection. Guard duty classifies finding under three categories: low, medium, and high severity, providing a clear overview of potential threats. In the AWS console, findings are color coded and marked with symbols based on their severity, making it easy to identify and prioritize potential threats. Amazon Guard Duty offers a reliable and efficient way to consistently monitor and protect your AWS accounts and workloads for suspicious activity. Have you ever wondered how to efficiently discover and analyze sensitive data stored in Amazon S3 buckets? Let me introduce you to Amazon Macki, a powerful tool that uses machine learning to do just that. Amazon Macki leverages machine learning to scan S3 buckets and recognize critical private information such as personal identifiable information, credit card numbers, API keys, and access credentials. It automatically tracks changes to buckets, making the discovery job significantly more efficient and scalable. Mackie provides a detailed list of findings displaying the severity, finding type, affected source, resource, and last scan date. For example, it can identify objects with personal, financial, or credential related data and indicate the severity as high, medium, or low. With Amazon Mackie, you can run one-time or automated data discovery and display the results to AWS Security Hub, ensuring the security of your sensitive data.